All right, the second kind of product is called a cross product. We are not going to be learning that this year, much to my chagrin, but Nyberg told me not to include chapter 11 this year, so. Yeah, he said even honors wasn't going to do it this year. So. Yeah? I don't know. He said it was hard because it's like 3-dimensional. I don't understand why that's any harder. But he was like, it's somehow harder to visualize. I don't know. We live in a 3-dimensional world. How is that hard to visualize, right? Anyways, a dot product always gives us a scalar. A scalar is a number, right? So like 1, 2, 3, 4. Let me give you some examples. So suppose we have u equals the vector 5, -1, and v equals 1, 3. The dot product of u and v is simply going to be 5 times 1 plus -1 times 3. That's what I meant by it's very similar to matrix multiplication, right? So you multiply the corresponding elements together, and then you add them. And that's it. Just kidding. There's a little bit more, but you guys can do questions 1 and 2 now. So a dot product is always going to give you a scalar, a number. Could be positive, could be negative, could be 0, but it's always a number. So the product of two vectors is not another vector, but rather a number. A cross product, on the other hand, would give you a vector. You'll see those in physics when you learn about... Nobody's taking physics here, though, right? You are?
I am.
Okay. Okay, do questions 1 and 2. Are there any questions about dot products? You multiply the components and then add them. So if you were looking for a formula, I can also give you one. Sorry.
Oh, word.
Okay. Cross products are quite a bit more complicated, so. I'll tell you guys the formula for a cross product.
We wouldn't need this though, right?
No, just for fun. Enrichment, you know? Made a typo. Okay, let's try to finish 1 and 2 in about 5 minutes.
We can do 2 as well.
Yeah.
Oh, I know what to do. I'm the girl.
Or don't matter yourself.
It's 0. Is it 0? Oh, A is -21.
What?
A is -21.
It's not -21.
-18 plus 2.
No, it isn't.
Okay, that's the formula for a cross product.
Is this square or?
No, they're not the same.
Yes?
For 1C, we square the I.
22 is B is 22.
I gave you 2 components, right? It's the same, just in a different form.
Wait, C is 0, right? Oh my god, bro. Get on my level.
Oh, it's just done.
I got it. It's C0. Okay. Basically. once like think about this like this. So they like yeah, it's zero. I got it right. I was like to ask you, it's like you don't like food and then you'll be like that. You bump. It's already done.
There's a restroom. X times X plus Y times Y. X squared plus Y squared. So,
So just let u equal this thing here, and then try to calculate the magnitude, and then u dot u as well, to see what the relationship is.
No, you know what? Why do you work? Yeah, I know you should right here, but you're like, wait, how do you do it now?
Yeah, it's like completely different.
But yeah, it is, but like, yeah. Maybe geometry, maybe you need to. I mean, no, this one.
Right?
You know, I never learned anything geometry.
Geometry is pretty similar to
Wait, I knew about.
It's probably more similar.
I knew sophomores were geometry.
Summer though.
They were on the football team, like. Huh?
I was just
No, I don't want to.
Yeah.
like, what are you saying, bro?
Yeah, exactly. So I'm saying so.
You can do something.
Kind of. Maybe you're like in the top echelon.
Yeah, just see what I
Okay, second off. What's the problem? What's the Can you explain? Oh, shoot.
Yeah, that's what I got.
Wait, I have no idea.
What? Romans 7, 21, 23?
Bro, literally like.
You like that?
I like all verses of the Bible, of course.
What's your favorite value to it?
I don't think I have one.
Where's your relationship?
I do, Luna.
He says he likes the verses.
All right, guys, let's finish up. I don't know, John 1930. Okay, that's u dot u. So what's the relationship between the magnitude and u dot u?
Magnitude?
All right, guys, let's talk about it. Huh? Good. Guys, let's start the rest of the lecture, okay? So number 2, the magnitude, if u is xi plus yj, then the magnitude is the square root of x squared plus y squared. Girls, quiet please. Magnitude is x squared plus y squared, and u dot u is equal to x squared plus y squared. And so that simply means that the magnitude squared is the dot product. Alternatively, we could also write that the magnitude is the square root of the dot product. Either is fine. Okay, so when we dot a vector with itself, we get the square of the magnitude. Pretty straightforward. Questions? Okay, let's continue to angles. Write faster.
Can you like go up a slight bit?
Watch the video, bro.
You were forced for a reason, right?
Let's talk about angles between vectors.
I said you were forced for a reason.
I
So,
like the number one viewer mismatch video.
okay, good to know.
Watch every single one of these.
So, vectors, we can actually calculate the angles between vectors using a dot product. And there's a very nice formula for it. That formula, which you do need to memorize, is that cosine of the angle between a vector, two vectors, that is u dot v, not u dot u, u dot v over the magnitude of u times the magnitude of v. Okay? If you, anyways, if you notice, this is two unit vectors being dotted together, right? So you can memorize it like this. So let's give an example. Suppose we have a vector u that's equal to 2, 1. And then we have a vector v that's equal to 1, 2. There's an angle between these two vectors, right? And that's an angle that we can calculate using the dot product. So if we were to apply this formula, then the cosine of that angle, theta, between the vectors is going to be equal to the dot product of 1, 2 and 2, 1. So u is 2, 1, and v is 1, 2. So the numerator is going to be the dot product between those two vectors. And then the denominator is going to be their magnitudes multiplied by each other. So we'll first calculate the magnitude of u, and then multiply that by the magnitude of v, which is 1, 2. Okay. And so the numerator is two vectors dotted together, and so that's going to be a number, right, a scalar. The denominator is two numbers being multiplied together, so that also gives us a number. It's very important to distinguish between what's a vector and what's a number. Questions so far? Okay, so the dot product between these two vectors is 2 plus 2, or 4. And then the denominator is going to be root 5 times root 5, because both magnitudes are equal to root 5, square root of 1 plus 2 squared. And so that's just 4/5, right? So our answer is going to be theta equals arc cosine of 4/5. Any questions? So we calculate the dot product and then the magnitude of both vectors and then plug them into the formula. Tyler. Well, cosine theta is equal to 4/5. So that means theta is going to be arc cosine of 4/5. Okay. Anybody remember what the domain of arc cosine is? 0 to pi. Yes, 0 to pi. So 0 to 180 degrees, right? And can you think of any two vectors that have an angle that's not 0 to 180 degrees? No, right? The smaller angle between two vectors is always going to be between 0 and 180. Even if it's acute or obtuse, or the other way around. It's always between 0 and 180. So arc cosine, we have no issues with the domain or range. And so that's all there is to it. So that's how you do question 3, all 4 parts. And then for question 4, you're going to want to use the same formula, except just rearrange it a little bit. That's my hint. And that concludes my lecture.